Now we will see the aspects of covalent bonding, salient aspects of covalent bonding. So we are aware that covalent bond arises due to the mutual sharing of electrons. Now we will have to revise the condition for the formation of covalent bond. We have seen that ionic bond is formed due to the factors, namely ionization energy, electron affinity, lattice energy and hydration energy. Here also, what is the condition for covalent compounds to be formed? First condition, the combining metals should have equal electronegativity. So if the elements, both the elements have same electronegativity, each of them will require electron. For example, let us consider this type of compound, chlorine or fluorine, fluorine molecule, hydrogen molecule, oxygen molecule. These are some of the examples where there is a covalent bond, one or more covalent bonds formed in these systems. Here both the elements are same. Same means they are equally powerful. Equal, what is meant by equal? So if we draw a line, this line denotes a pair of electrons. One electron coming from each atom. So this line can be replaced by in this fashion, one cross and one dot. Cross refers to one chlorine atom, dot refers to another chlorine atom. Belongs to one chlorine atom, belongs to other chlorine atom. Here also two fluorine atoms, each of them equally powerful. So this is called central electron pair. So since they are equally powerful, this electron pair cannot move towards one of the atoms. They are equally powerful. If you take the case of HCl, chlorine is more electronegative than hydrogen. So central electron pair, chlorine tends to attract hydrogen's electron also. Electron pair means one from hydrogen, one from chlorine. But both the electrons are attracted by chlorine because chlorine is more electronegative than hydrogen. But here both are equally powerful, they will be equally attracting. So the central electron pair will not move towards any of the atom, it will be strictly only at the center. Or in other words, this also outermost electron is 7, another chlorine atom outermost electron is 7. So both the chlorine atoms require one electron for their octet configuration. So the both requirement, it is like a compound wall. Both people they want some compound wall, means compound wall is the common property for the two houses. Here also the central electron pair is the common property for both the atoms. For both the atoms, it cannot move towards. That is why it is called combined. So combined means equally powerful. If the materials or elements are of equal electronegativity, so such type of elements will form covalent compounds. Examples are oxygen, nitrogen, hydrogen, chlorine, individual. These are called, so oxygen, it will be represented, nitrogen, triple R, hydrogen, single bond, chlorine, single bond. Because both are equally powerful, so central electron pair will not move towards any of the atoms. If it moves towards one of the atom, it will be becoming ionic. Here it is, we are discussing covalent. Covalent combining capacity, covalent bond is to be considered as formed when the participating atoms have equal electronegativity. Equal power of attraction of central electron pair towards it. If they equally attract, it will be only at the center. That is. Now then we will see what is the reason for the multiple linkages, etc. So hydrogen each shared this electron, the two electrons, it acquires helium configuration. Chlorine acquires 8, outermost 8. Nitrogen, if you take the case, nitrogen atomic number is 7, 2,5. So in order that it attains electron octet configuration, it has to occur 3 electrons. But both the nitrogen atoms require 3 electrons. So none of them will give 3 electrons for each. That is not possible. So the 3 electrons will come at the center. Both require 3 electrons, means 3 electrons. Each 2 electron pair is coming at the center. If we take the case of oxygen, oxygen atomic number is 8, outermost is 6. So 6 means it each oxygen atom requires 2 electrons. So this also requires 2 electrons, this also requires 2 electrons. So each electron pair is denoted by one covalent bond. So there are 3 covalent bonds in the case of nitrogen. There are 2 covalent bonds in the case of oxygen and 1 covalent bond in the case of hydrogen, chlorine, etc. So to condense and revise, covalent compounds are formed between the atoms which have equal electronegativity. Next one, the covalent compounds are represented by Lewis formula in general. So we have drawn different types of linkages. Oxygen we draw double bond, nitrogen we draw triple bond, hydrogen we draw single bond. What does it mean? Everywhere the lines refer to each line, or it is called bond. It refers to a pair of electrons. One electron coming from each atom. So there are a pair of electrons from oxygen, a pair of electrons from another oxygen atom. Similarly, each pair of electrons, 3 totally, from each nitrogen atom, only one pair of electrons existing between hydrogen. That is to be noted. This is called Lewis electron dot formula. Electron dot formula means dots and crosses are used to represent the electrons between 2 atoms. So this to be noted. This is Lewis formula. In this Lewis formula, you can arrive at how many electrons are there, or what are the electrons. So now we will have to segregate the type of electrons. In general, the electrons between 2 atoms in covalent bonding, they are to be noted 3 types of electrons. We will see in molecular orbital theory later. Now we have to remember these, what does mean by these type of electrons: bonding electrons, non-bonding electrons and anti-bonding electrons. So the type of electrons which involve in the compound stability, these are to be noted: bonding electrons, non-bonding electrons, anti-bonding electrons. Bonding electrons means if it is such electrons will tend to increase the stability of the molecule. Increase the stability of the molecule. Whereas non-bonding electrons, they will neither increase nor decrease the stability. Anti-bonding electrons, they will decrease the stability of the molecule. So the stability of the molecule is either increased or decreased or does not get disturbed by the electrons. That is meant by non-bonding electrons. This we can illustrate well in the molecular orbital theory later. That just we have to note it, recall this point. So what is maybe bonding electrons, anti-bonding electron, non-bonding electron. We will come to that later. Now already we have seen about the case of hydrogen chloride. So what is the state of hydrogen chloride? Hydrogen chloride is ionic compound or covalent compound. If a question arises, another type of question arises, whether it is in gaseous state or in liquid state or aqueous state. Aqueous means dissolved in water. So we can draw 2 types. Let us illustrate. Hydrogen, its atomic number is 1. Chlorine, atomic number 17. So 17, the electrons are distributed 2, 8, 7 here. So the nearest inert gas to hydrogen is helium. It requires 1 electron so that it occurs helium configuration. Helium near argon. So chlorine nearest, this also requires another electron to get argon configuration. So both require 1 electron to arrive at. In that case, 1 common pair exists between hydrogen and chlorine. So hydrogen also chlorine, that is to be noted. So hydrogen chloride, this is, but sometimes we will write it as H plus and Cl minus. So in solution stage, when it is dissolved in water, it exists as H plus and Cl minus. If it is not dissolved, it is only existing as gas, it is only covalent bond. So hydrogen, the linkage between hydrogen and chlorine is covalent, more covalent in gas phase and more ionic in aqueous phase. Aqueous phase means dissolved in water. So what is meant by, so this is called partial covalent character or partial ionic character, or in other words, we have to study or recall a concept called what is meant by polarity of covalent bond. Polarity. So the term polarity has to be carefully distinguished from the term ion. So compounds are of two types, polar compounds and ionic compounds. What is the difference between the two? Both will be acquired with the charges. Polar compounds also involve charges. Ionic compounds also involve charges. But ionic compounds, the charge is integral, +1, +2 or -1, -2, whatever be the case. There is no fractional charge in the case of ionic compound. If you take the case of sodium chloride, Na plus Cl minus. If you take the case of barium sulfate, Ba2 plus SO4 2 minus. If you take the case of aluminium phosphate, Al3 plus PO4 3 minus. In this way. So the charges are always integral positive charge or integral negative charge. So integral positive charge or integral negative charge, that is the characteristic aspect of ionic compound. Whereas polar compounds, water is called polar solvent. Water is called polar solvent. Polar solvent means water will not dissociate into H plus and OH minus. If it dissociates into H plus and OH minus, water will be a good source of acid, good source of base. It will not at all serve the purpose of drinking. So it should not be the case. It is, we are so fortunate enough to have polar nature of water. If it is ionic, things will be quite critical. That is to be noted. Polar characteristics also required. Means that polar means fractional charge characteristics. Fractional, how to illustrate fractional? So already we have seen that water is a, we will see the detailed aspect about the structure later. Now water is a non-linear molecule. So this is the structure for water. So there is one oxygen atom connected to two hydrogen atoms. So oxygen atom is called central atom, hydrogen is called surrounding atom. So each oxygen atom in water molecule is surrounded by two hydrogen atoms. So, but oxygen is more electronegative than hydrogen. More electronegative than, so this line represents one electron each coming from oxygen and hydrogen. Oxygen and hydrogen. But oxygen is more electronegative means it will tend to attract hydrogen's electron. So it becomes, so hydrogen's electron goes to oxygen means oxygen becomes slightly negative charge. It is not fully negative charge. Hydrogen becomes slightly positive charge. So this is called Greek letter delta. Delta stands for the fractional positive charge. If one atom is more electronegative than the other, central electron pair will move towards more electronegative atom. If the electron pair moves towards the other atoms, hydrogen's electron also goes towards oxygen. So it is electron rich. So electron density is more. Hydrogen becomes electron deficient. So there is a partial fractional positive charge established in the case of hydrogen atoms. Fractional negative charge established. So this is called fractional charge characteristics or called polarity. Polarity is nothing but fractional charge characteristics. So in that sense only water is called polar solvent. It will not dissociate into H plus and OH minus. That is to be noted. So in the case of covalent bond, because of the difference in electronegativity, there is a phenomenon called polarity of a covalent bond. So in this case, what is the significance? Why we have to discuss about polarity of covalent bond? If you take the case of some ionic compound, it will behave like a covalent compound in some places. If you take the case of covalent compound, it will behave like a ionic compound. So the question mark, that is why partial covalent character, partial ionic character. Simplest example is hydrogen chloride. So hydrogen chloride is more ionic in solution phase, more covalent in gas phase. So there is a competition between covalent character and ionic character for HCl. So this is called polarity of covalent bond. What is the, so covalent, if they are equally powerful, it will be neither ionic nor covalent. If one of them predominates, accordingly it will be more ionic or covalent. So for this they have given a empirical relation. They are comparing this difference in electronegativity. X stands for electronegativity. Electronegativity is the capacity to attract central electron pair. So if you consider any compound between two atoms A and B, if Xa is the power of attraction of A to attract the central electron pair towards it, Xb power of attraction of B to attract the central electron pair. This Xa minus Xb is greater than or less than or equal to 1.7. Accordingly, the compound will be ionic or covalent bond. So you have to remember only one point. If you remember only one aspect, other aspects can be derived. If it is more than 1.7, so the difference between the electronegativities is higher than 1.7, ionic character will predominate. Ionic character will automatically, you can tell. If it is less than 1.7, covalent character will predominate. If it equals, none of them will predominate. Equally ionic and equally covalent. That is to be noted. So, why a compound behaves as, so HCl is ionic in liquid phase because the difference in electronegativity of hydrogen and chlorine is more than 1.7 in aqueous phase or water phase. If it is in the gaseous phase, it is less than 1 point. So, in gas phase less than 1.7. The same thing, that is to be noted. Or in other words, the difference in electronegativity itself is a function of state of material. In the gas state, it is less than 1.7. In the aqueous phase, it is more than 1.7. That is why it is more ionic or more covalent. In the case of water, always it is less than 1.7. No question of gas phase or whether H2O is in the solid state or liquid state or gaseous state. Solid state it is called ice. Liquid state it is called water. Gaseous state steam. Ice or water or steam, in none of the cases the difference in electronegativity is more than 1.7. It is always less than 1.7, so that is it is always covalent. So the compounds can be covalent or ionic depending upon the polarity of the covalent bond. Polarity is decided by the difference in electronegativity. Now lastly, let us compare these compounds: NaCl, NaBr, NaI, NaF. So all are sodium halides: sodium fluoride, sodium chloride, sodium bromide, sodium iodide. All are supposed to be ionic compounds. Already we illustrated NaX in general, ionic compound formation. We have studied. Here, cation is Na plus common in all the cases. But anion is halogen in general, but nature of halogen varies. Fluoride, chloride, bromide and iodide. If you compare the partial covalent and ionic characters, the most ionic compound is sodium fluoride, whereas most covalent compound is sodium iodide. So, ionic character decreases from left to right. Covalent character increases from left to right. So, that is why, because the hydration energy is a function, already we have seen about the lattice energy and hydration energy. So, this lattice energy or hydration energy is a function of size of the anion. Higher the size of the anion, the hydration energy is higher or lattice energy is more, so that it assumes covalent. In order not to confuse that hydration and lattice energy, let us see only the influence of polarity of a compound. Polarity or partial covalent character of a compound depends upon the charge on the anion and charge on the cation and size of the ion. In general, charge on any ion. Charge on any ion and size of the ions. So, this is charge as well as size on ion. This is influenced by an important rule called Pajon's rules. So, he proposed Pajon's rule. He compared the size of the cation and the anion, and thereby, depending upon their size and numerical charges, they introduce fractional, whether it is fractional or integral, whatever be the case. So, they introduce polarization power. Polarization power. So, we got to be careful about this term. The same term will take different definitions in different areas. Polarization, optically active compound, capacity to rotate plane polarized lights. In physics, capacity to separate the charges. In capacity to separate the charges. Here also charges are separated, but fractional separation. So polarity of a covalent compound or polarization characteristics or polarization power is directly related to the anionic size. First let us state the facts, then we will explain. Then it is inversely related to the cationic size. Third one, it is directly related to the cationic size, inversely related to the cationic size, directly related to the charge on any ion, whether it is cation or anion. So polarization here what we mean? Polarization is the polarity of covalent bond. Polarity of covalent bond is called polarization. Capacity to attract the central electron pair towards a particular atom. Because so polarization power is more if the anionic size is more. Polarization power is more if the cationic size is less. What is meant by, let us compare these two. The same examples. NaF, NaCl, NaBr and NaI. One case. HCl, LiCl, NaCl. So HCl, LiCl, NaCl, rubidium chloride, cesium chloride, rubidium chloride, cesium chloride. We are comparing. In both cases, first one is the variation in the anions, keeping the cation constant. Second one is the variation in the cation. Chlorine is common, hydrogen, lithium, sodium, rubidium, cesium, francium chloride. Now, if we compare the covalent and ionic characteristics of sodium halides, sodium fluoride, sodium chloride, sodium bromide and sodium iodide. You have to bear in mind these points. So, this compares the anions. So, polarization is directly related to anionic size. Means that here from sodium fluoride to sodium iodide, cation is common, only sodium. But anion, fluorine, chlorine, bromine, corresponding elements are fluorine, chlorine, bromine, iodine. These are group elements. Along the group, we have seen that size increases. So, periodic property. So, from sodium fluoride to sodium iodide, there is increase in anionic size. So, if there is increase in anionic size, more polarization. So, polarization characteristics increase from sodium fluoride towards sodium iodide. So, sodium iodide is maximum polarized. Maximum polarized means it is maximum covalent. So, this is minimum polarized or ionic. So, in this combination, sodium fluoride is the most ionic compound. Ionic character decreases from sodium. So, if you take the case of between two, they are of competitive, covalent and ionic characteristics. So, it is most ionic with respect to sodium fluoride, most covalent with respect to sodium iodide. This we have compared with respect to anion. Next is the comparison with respect to cation. Polarization is inversely related to cationic size. Now let us compare keeping the anion constant, different chlorides. Chloride is fixed. Hydrogen chloride, lithium chloride, sodium chloride, potassium chloride, rubidium chloride, cesium chloride and francium chloride. So, in all cases, anion is only chloride, fixed, but cation. So, these are form the first group elements, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. These are alkali metals. So, hydrogen is not alkali metal, but electropositive nature. So, from hydrogen to francium, size increases. So, but size is inversely related. Lower the size, polarization is higher. So, lower size, cationic size is lower. Lowest is HCl. That is why we think of only in terms of HCl, partially covalent, partially ionic we talk. We don't talk about francium chloride. So ionic character, cationic size is small means polarization is large. Polarization is large means covalent character is large. So covalent character, most covalent is HCl, least covalent is francium chloride or more ionic. So we got to be careful. This with respect to cationic and anionic comparisons. Lastly, charge on ion. Let us come. So far we have compared only charge. Now, what is the another term coming into picture? Charge. Let us compare these two compounds. NaCl and magnesium oxide. Lastly, NaCl and magnesium oxide. Na plus Cl minus. But Mg2 plus O2 minus. How many electrons are transferred from one atom to other atom? That is referred by charge. So, so far we have considered only positive charge, plus 1 or minus 1, plus 1 or minus 1. Everywhere the magnitude of the charge was only unity. Here the magnitude of charge increases. Sodium chloride and magnesium. So, more polarization means, so magnesium oxide is more covalent than sodium chloride. Why? Means that magnesium oxide charge is magnesium 2 plus, oxygen 2 minus. Here it is only 1 plus, sodium chloride 1 plus 1 minus, 1 electron transfer. Charge on the ions, all are ions, sodium ion, magnesium ion, oxygen ion, chloride ion. But charge is higher. In the case of, if you compare sodium and magnesium, magnesium loses 2 electrons. If you compare chlorine and oxygen, oxygen gains 2 electrons. So charge on the ion is greater means polarization is greater. Polarization is greater means covalent character is greater. So comparison of covalent character and ionic character in terms. So this is the essence of Paget's rules. So Paget's rule compares the sizes of anion, cation and integral values of charges on the ions which influence. That is why the compounds behave partially covalent and partially ionic. Ionic behavior is predominant or covalent behavior is predominant. That is deduced only by the Paget's rules. Polarization phenomenon, that is to be noted. All these are based on the polarity of covalent bond. Polarity of covalent bond. Now we will illustrate individual bond characteristics. Now we have to discuss the covalent bond characteristics. What is meant by covalent bond characteristic? First let us list, then we will discuss in detail. Bond length, bond angle, bond order, bond length, bond order, bond angle, bond energy. These four are the important ones which describe. So sometimes we draw single bond, sometimes we draw double bond. Double bond means both are covalent bonds. Single bond means only one covalent bond. Double bond, two covalent bonds. Triple bond, three covalent bonds. But somehow all the three will not be of same strength. All the three will not be of same angle. So once we write, already we have seen. Here we write it in angular fashion. Here we write it as linear fashion. Here the angle between the atoms is 180 degree. Here the angle between the atom is less than 180 degree. So linear molecule and non-linear molecule shapes. All these are influenced by these important phenomenon: bond length, bond order, bond angle and bond energy. We will illustrate them with examples. What is the significance of this? In general, bond length is shortened means compound becomes more stable. Bond length is long means compound becomes less stable. It is equivalent to your forces of attraction. Force is inversely related to the distance between the atoms. So bond is large means atoms are separated. If the atoms are separated, the inter-atomic forces are getting reduced. So they are bound by little force. They can easily escape. Similarly, bond order. What is the significance of bond order? Bond order is 1 for hydrogen. Bond order is 2 for oxygen. Bond order is 3 for nitrogen. We will see what are. Then bond angle. Both are carbon-oxygen bonds. Here carbon-oxygen bonds are held together by an angle of 180 degree. Both are oxygen-hydrogen bonds. Oxygen, the angle between two oxygen-hydrogen bonds is less than 180 degree. That is meant by bond angle. Lastly, bond energy. Bond energy is the energy required to break a bond or energy released in establishment of bond. Once again, we will illustrate with the definition with examples these terms. Bond characteristics of a covalent bond or covalent